Hello everyone and welcome to my presentation. Today I want to talk about potential penetrative pass, or let's just call it P3 in short. Before jumping into the presentation, I want to introduce myself. I am Hadi. I'm a football data science consultant and I have worked with clients like Dutch Football Association in past. I am the third place winner of the Paris Saint-Germain Sports Analytics Challenge, and the image that you see on top is exactly my talk back there in Paris in 2019. I also hold a data science professional doctorate in engineering from the Eindhoven University of Technology. And I think it's clear I am also a Chelsea Football Club fan and very happy that this conference is organized at Stamford Bridge. Let's go back to 2009, Barcelona under Pep Guardiola, one of the most successful teams in the history of football, and well known for playing this kind of passes into the space of the opponents, which were they were calling them tiki-taka, and that was a pattern: just find a space into the convex hull of the opponent players and progress towards the goal to score and win a match. We can see this pattern again here from Busquets passing the ball to Messi. And that's exactly the topic of our study here. You are interested in defining and studying penetrative passes, and the most important, the potential penetrative passes. But first we need to know what we mean by that. Let's assume the blue team is playing from left to the right of the pitch, and we have the red team playing from right to the left of the pitch. At this moment, player number 5 is on the ball, and when we look at all the players in front of the ball, we can see that the red players can create a convex hull if we exclude their goalkeeper. And at this moment, player number 5 can play the pass into player number 10 inside this convex hull. Maybe he has another passing option to player number 11 and also player number 8. Maybe the pass to player number 8 is a bit difficult because player number 9 of the red team can intercept. The player number 5 also has other passing options, player number 6 and number 7, or maybe he can just play the ball backwards to their defense. If in this passing moment the ball ends up in the opponent's convex hull that we have drawn here, we call it a penetrative pass. And the condition is that there should be at least a blue player inside the convex hull to receive the ball. So this moment is a potential penetrative pass, and if the ball ends up in the convex hull, it becomes an actual penetrative pass. Since these kind of passes can happen all around the pitch, they can happen when you are in your build-up and in your first third of the pitch. They can also happen when you are very close to the opponent's goal and getting into the box. But for this study, we are only interested in the passes that have originated or have the start location above the first third of the field and also before the last fourth of the field. And the reason is that when you are in your defense, your concern is not really to play a penetrative pass. You just want to have your build-up and move to the next phase. And when you are in the last fourth of the pitch, you want to score a goal. So you should not get credited because of playing penetrative passes. You should get credit because of scoring goals. And the task and the question that we have in this study and we want to answer is that, given a passing moment, what is the probability it becomes a penetrative one? Here we have Tottenham players on the ball, and because of the way that the Liverpool players are positioned and the compactness that they have and the distance between their adjacent players on the convex hull, all this stuff makes it very difficult for the Tottenham players to play a penetrative pass based on the definition that we have. So they force the player, the white player, to play to the sides. And we expect that by the end of this study, we have a model that when we give the model this image, or basically this frame as an input, it tells us the probability is very low to have a penetrative pass. let's see what kind of data sets we have access to conduct this study. We have access to event data of a StatsBomb. Basically, we know the information of the passer, the X and Y location. We know the information on the receiver, and we know whether the pass was under pressure by the opponent player or not. We also have another data set, a 360, basically their new data set of a StatsBomb. And we have access to all players that are visible on the camera frame. And it provides basically more information, and also it's, let's say, an enriched event data compared to what we had before. So for this study, we had the matches of the top 10 teams in Bundesliga. That means we had 245 matches, and it means 79,000 passes based on the conditions that we have described are in our data set. We also have La Liga matches, 284. And with these two basically different leagues, we are going to continue our study. So let's see how we want to approach this problem. We have an input X as basically the passing moment, and we want to have the output Y, which means that whether the passing moment can become a penetrative pass or not. If we know the exact relationship between different variables, we can just write the function f, basically getting all those variables as an input, and then just produces the output y, whether it's a penetrative pass or not. But because we don't know exactly how all these variables in data work with each other, that's why we are going to follow a machine learning and deep learning approach. And the basic idea is that we want to estimate this function f using a function called g that we are going to learn in this study. For the training and validation purpose, to basically build our model and validate that, we are going to only focus on Bundesliga matches. And when we have our model ready, to highlight the applications, we are going to use La Liga matches. So in this way, we can make sure that there is really no data leakage issue that we are training and validating and basically using in production on the same data set. Since the data set is very imbalanced, we have 88% of the passes non-penetrative and only 12% of them penetrative. That's why we cannot use accuracy as our evaluation metric, and we use AUC-ROC. For people who don't know what is AUC-ROC, just assume it's a score between 0 and 1, and the higher the score is, it means the model is better and it's more reliable. But to have an objective in this study, in applied psychology and prediction of future behavior, they define, let's say, AUC-ROC of at least 0.7 or higher as a goal in their studies, and that's exactly the same here. So if we can meet this objective, we will be happy at the end of this study. Okay, let's see different methods that we explored. The first one is only based on the event data attributes that we have. So focusing only on the X and Y coordinates and whether the pass was under pressure or not, we want to see how our model performs. But because we want to be independent of the passer and the team, we exclude information like whether the pass was with a right or left foot, or what is the passing information or accuracy of the team. So no matter in this situation that we see on top, Chelsea is on the ball, or maybe another team is on the ball. So we are interested only on how the players and everything is basically on the pitch. It's very important to mention that we are not using the information of the end location of the pass, because we know the value of that when the pass was given. And to be concise in a scientific way, and don't have a data leakage, we are not going to use the end location. Here we can see the performance of different well-known machine learning algorithms. Basically, we can see really it doesn't matter if we use random forest, XGBoost, LGBM, CatBoost, or Extra3. All of them are going to give us more or less the same validation in terms of AUC ROC. And that's a clear sign that it's not because of the models that we or algorithms that we get a low AUC ROC. It's because that the data set that you're using, basically event data, doesn't have enough information for this study. That's why we continue with StatsBomb 360, and we want to see how we can improve the results of method 1. Following up on the convolutional neural networks or CNNs on images, for people who don't know what CNNs are, let's assume that you are, as a human, you are a model, let's say. And when you are given with two images, on the left side a cat and on the right side a dog, it's very easy for you to determine which one is a cat and which one is a dog, because you have learned how to interpret images and understand them. And that's the same idea for convolutional neural networks. We want to use these models to basically distinguish between images of penetrative passes and non-penetrative passes. But let's see how we are going to do that. Using first, we need to basically draw the image that we are going to use for our CNN algorithm. Let's assume that the on-ball team is always drawn in blue and they play from bottom to top of the pitch. And the off-ball team is always in red and they play from top to the bottom of the pitch. And when it goes to the passer, we show him or her in black. And at the end, we can have an image like this. So we also have some other information here basically encoded. For example, a Voronoi diagram is used to show the space that each team is controlling. Also, we have the space controlled by the passer in black. We also show the convex hull in green, and we hope that when all these colors overlap with each other, it provides enough, let's say, information for our CNN model to learn how to distinguish between penetrative passes and non-penetrative ones. Regarding the architecture that we used, we followed up on the technical transfer learning. Basically, a model called ResNet34 was trained on 1 million images with 1,000 different categories, which is a famous dataset called ImageNet. And we are going to use that model as our initial model and then fine-tune it on the task that we have here. So ResNet34, and when we fine-tune it, and after 8 epochs with GPU, which took for, let's say, almost 2 hours to do the training, we have a 0.3 as our training loss, and we have a validation loss 0.33. Basically, the loss means in the training and validation that we are not overfitting. And when it comes to the validation AUC ROC, we have 0.73. In the beginning of the study, we said if we can get 0.7 or above, we should be happy, and that's exactly the moment that we can be happy that we have a model that basically has met the objective that we have defined. And when we look at the AUC ROC curve, on the x-axis we have the false positive rate, and on the y-axis we have the true positive rate, and we can see how this curve basically is. And exactly the ROC curve shows 0.73 as basically the metric that we used. But because we are dealing with probabilities, and probability of a model can be 20%, 30%, 40%, we need to have a threshold to really cut off and say if Any probability is above a specific threshold, we are going to report it as a penetrative pass, and if anything is below the threshold, we are going to report it as a non-penetrative pass. That's why, following up on the minimum distance Euclidean of the point on the curve to the point on the top left, 0 on the x-axis and 1 on the y-axis, we end up with the probability threshold of 10.38%. So it means that assume you have a passing moment, and the model that we have trained tells us the probability is 20%. Because it's above this threshold, we say it should have been a penetrative pass, and it had the potential to be a penetrative pass, basically. But if it's below this threshold, let's say the model says, like, assume it's 5%, we say we don't expect it to be a penetrative pass because it's below this threshold. Let's go to 2 examples and see how our model really behaves in practice. At this moment, Boateng is on the ball and he wants to pass the ball. He's going to play a penetrative pass, but because of the situation, our model says the probability was very low. It was 0.4% for this pass to become a penetrative one. And let's see why. So this is exactly the passing moment, and we can see the convex hull, we can see the player who is going to receive the ball, and maybe based on our intuition, it's also a very difficult penetrative pass because the receiver is almost at the end of the convex hull, and a lot of the space in the convex hull is controlled by the red team, and all this stuff makes it difficult passing a penetrative pass, and also the reason why the probability is very low. Okay, let's see. Here we have another example that on the pitch it was not a penetrative pass, but our model was telling us the probability is very high, it's 66% to be a penetrative pass, and let's see why. So at this moment, the Borussia Dortmund player is on the ball. He can play a penetrative pass, but he decides to play to the side. And you see here, Erling Haaland is very desperate to not be given this chance, and for his teammate to not play a penetrative pass towards opponent's goal. Let's see this video clip again. Okay, so far we have defined what is a penetrative pass, what we mean by a potential one, which approaches that we followed, and what is the performance of the model that we are going to use. And now it's time to jump into the application side. The first application is player recruitment. First, we basically group all the players in La Liga from the top 10 teams into defenders, midfielders, and under 23. We are not interested in strikers and goalkeepers because we think that their main job is not to play a penetrative pass. The goalkeeper should not concede a goal, and the striker should score a goal. But really it depends on your game model, and if you are interested in a goalkeeper who plays a penetrative pass or a striker, you can also do the same analysis there. And we should also have some conditions on the players. The play time should be at least half of the matches. And also the median of the actual penetrative passes the player has given should be the median of his group. So in this way, we make sure that we don't end up with a player who has played only 1 or 2 or 3 matches, and he only had 1 or 2 or 3 penetrative passes. So in this way, we can make sure that we have basically reliable results. And now it's time to introduce this KPI, P3 percentage. basically it's the number of successful penetrative passes divided by the number of potential penetrative passes a player had. And the higher, the better. So instead of only looking at the penetrative passes as an absolute number, we want to contextualize it and compare it to the number of times the player had the potential to play a penetrative pass. Let's look at the defenders in La Liga and which ones are on the top of our list. Samuel Umtiti, with 48% of the times that he had the potential to play penetrative pass doing so, is on the top of our list. Then after that we have Yuri Berchiche, and we also have in the third rank Pau Francisco. Going to the midfielders, we see that Lucas Torreira with 42% is on top of our list. He was playing at Atletico Madrid on loan from Arsenal at that moment, and in the current season he plays at Fiorentina. In the second rank, we have Toni Kroos with 39%, and then after him we have Sergio Busquets and Frenkie de Jong with 39%. And when it comes to under 23 players, it's very interesting that Rodrigo Silva from Real Madrid is on top of our list with 54% in this KPI. And then after him, we have Diego Lainez Leiva and Joao Felix. We can do the same analysis in the team level. So instead of having the player recruitment application for the performance and opponent analysis, we can just do the aggregation and look which teams are tending to play penetrative passes compared to the opportunities that they have. Not surprisingly, we have Barcelona on top of our list with 32%, and then Villarreal and Atletico Madrid after them. Maybe we can credit the head coach and the coaching staff because of this performance. We can also flip around and look for the teams who give a few opportunities to the opponents in terms of potential penetrative passes. And that's why here we see Sevilla only giving 52 potential penetrative passes to the opponents per match, and they are on top of our list. And it's very interesting when we look at the bottom of the list, we see Atletico Madrid and Granada. For the coaching staff, who spend a lot of time to go through individual cases and study them, how everything went, we have developed a small dashboard here that I'm just going to play. So assuming you're a coaching staff, let's say at Real Madrid, you select the team, Real Madrid. Then you select which matches you are interested in to study this P3 KPI. We say we are interested in all matches, and then we are interested in a specific player who was on the ball, and we want to see how he performed in different situations. So we say Toni Kroos. And the next filter is just show me basically the penetrative passes that he had, and only the top 10 based on the probabilities. And when we say scan, it's going to show us the low probability situations that became a penetrative pass. So we didn't expect them to become a penetrative pass, but the player really played a penetrative pass. And here, for example, we can see that on the right side, basically because of the way that the convex hull is created and the red team players are positioned, and where the passer is, it was a very difficult pass to give and have a penetrative one. But Toni Kroos was able to do that, while our model was saying the probability was 0.16%. And the same thing we can exactly see here again on the right side. We have another example. Again, very difficult to have a penetrative pass, but Toni Kroos was capable of doing that. And this dashboard, which we call it just P3 Explorer, gives this opportunity for coaches to jump into different and individual cases. They can just look for the situations that they were not a penetrative pass, but maybe they had a very high probability. For example, here, Toni Kroos was almost close to the convex hull, so it should not be a very difficult task to play penetrative pass, but he was not giving a penetrative pass. And here you see the probability was 71%. But we should keep in mind these images can be a bit misleading, because maybe if you look at the video footage, the body orientation of the player, he was basically towards his own goal, and he was not seeing his backwards. And that's what we don't have in 360. And that's why it's very important to not use these images in the dashboard, but if we have access to the video footage and the video clips, to replace these images with those dynamic videos. And the same here, different situations. That it really depends on how players are positioned on the pitch. For example, to just explain this one on the right side, it seems very high probability and very easy, basically, penetrative pass to give, because the distance between these two red adjacent players is very high, and also the angle that they create, it makes it perfect, let's say, moment. And also because the blue player is really not under pressure by the opponents, and he has enough space behind. Okay, we can just go to the next slide. And as I mentioned, it's going to be an interesting application for the end users when we have access to the video footage, and we can just directly and in an automated way connect these situations to the video clips. Maybe in the near future, we can see these kind of applications in media, basically after a match in a post-match analysis. Here we have Gary Neville, maybe at some point using this kind of KPIs, and in this kind of dashboards, they can just jump into different situations and evaluate how players make decisions in different scenarios. And for the discussion part and future work, I think it's very important to mention that the camera angle plays an important role, because we are using 360 data. We don't have information of the players who are not on the camera. So that can have impacts on the way we calculate the convex hull. For example, if the camera is only showing a few players from the opponent team, so the convex hull that we basically draw on the image is not the actual convex hull, and we should keep in mind. We saw that the player orientation, basically the body orientation, has an impact, and we don't have it in the data. So that's why it's very important to judge players based on exactly the video footage and not these static images that I show. Maybe someone is interested in questions like who are conservative players, and it's very important to mention that maybe a player plays a very good penetrative pass, but because it's not in the convex hull that we have in this 360 data, because the actual convex hull is a very bigger one. That's why we should be conservative in blaming players. We cannot answer this question, who are the conservative players in penetrative passes. Maybe another application can be looking for optimal positioning of the players if we change their position and see how the probability of the model increases or decreases. And other applications following up on the same framework, maybe we can have a potential cross or potential counter-attack. As a conclusion, we introduced potential penetrative pass. We said how the model performs if you only use event data. And if you use CNN with 360, we can meet the objective that we have. And in the applications, we discussed player recruitment, performance and opponent analysis, and media. And also if someone wants to follow up on this study, what are the next possible steps? Before ending my presentation, I want to thank Katie from StatsBomb, who was responsible for communicating and making everything possible to prepare this presentation, and also Will Thompson, who is a data scientist at StatsBomb, and I had with him several meetings to improve the quality of this presentation, and everyone else at StatsBomb for organizing this great conference. And at the end, since I'm not at the conference in person because of COVID restrictions, I want to thank you all for listening to my presentation. And if you want to get in contact, just use my email, hadisutude1992@gmail.com, or if you are on LinkedIn, just type Hadi Sutude and you will find me there. Thanks a lot, and I hope you will enjoy the rest of the day.